All right, good morning, folks. Really excited to have this webinar today. And my name is Fred Pollender. I'm the Assistant Director for Career Development and Experiential Learning at Oregon State University in the College of Earth, Ocean, and Atmospheric Sciences. And one of my jobs is to help students with career readiness. And I'm really excited today to welcome our guest speaker, Neal Colwell. Neal's going to give us some in-depth description of a project that his firm has been involved with, and our students who are interested in environmental consultancies, permitting, and collaborating with state agencies on projects, I hope will gain a lot from this presentation today. So without any further ado, I want to introduce Neal Colwell. Welcome, Neal.
All right, Fred, thank you very much. Appreciate this opportunity. Appreciate Oregon State University allowing us to present on our project here this morning. So what I'm hoping to do with this morning is have a discussion, probably a little bit of a technical discussion here about this project, but really kind of give it a context into the various team members that were involved in identifying the project, um, uh, identifying the alternatives, and then really involved through the project planning, design, implementation, and now into the operation of this particular project. Um, this is a project that was constructed nearly 10 years ago in Sacramento Valley, California. And it's related to providing some infrastructure to help resolve or come up with kind of a best solution to address multiple issues and challenges in this area regarding water resources and habitat and endangered species as well. So overall, this project's objectives dealt with availability of water for irrigation to a very productive part of the Sacramento Valley, coupling that with an ability to provide for effective flood management and flood control. And then the overarching objective of this project here was to improve conditions for one of the most impacted communities here of salmonids in the Sacramento Valley, the winter run salmon. So I want to present some technical background on this, but really talk a little bit about the structure of the team as well that implemented this. Again, overall presentation here, go through the introduction, talk about the details of the project. Again, the entities that are involved in that. Go through some of the project planning and implementation phases and how those teams work together for this to be successful. Go through the project objectives, and then ultimately wrap up with some of the project outcomes. And then I do want to spend some time here with any questions that may come up. And as Fred mentioned, if there's questions here during the presentation, please raise your hand, put the question into the chat box, and we'll pause and answer those questions.
Great.
So I want to just go through a little bit about who I am, a little bit of the bio of your speaker here, if you will, and just kind of give you the perspective. And again, looking at this from a variety of career paths that people can take, and how you can navigate opportunities for yourself in the future. So as I mentioned, I'm an engineer, a civil engineer, but I took a little bit of an unusual path in my educational career, where I started off, went into and went through a 5-year program that had a combination of a Bachelor of Arts and a Bachelor of Science. And so that 5-year program started at University of California, Santa Cruz, and then wound up at UC Berkeley. So started at UC Santa Cruz and went through a 3-year program there to get my Bachelor of Arts in Environmental Studies. Couple that up then with civil engineering at UC Berkeley. So I was able to bring from an educational perspective those two backgrounds to what I think really supplemented and expanded what would otherwise be a purely technical degree in civil engineering, incorporating those environmental resources, cultural resources aspects of environmental studies into my career. So that was early 90s. I'll jump down to the bottom of the slide here. Spent about 3 years with the U.S. Peace Corps in Ecuador, working with rural communities in developing water supplies, helping rural communities manage wastewater as well in Ecuador through the Peace Corps. Came back to California, that's where I'm from, and started working in the private sector, but decided I wanted to go back to get my master's. And so that's where my selection led me towards Oregon State University. And between 97 and 99, I got my bachelor's or my master's of science in civil environmental engineering at OSU. So really happy to have this opportunity here to come back to this school that was for me very influential in terms of the cap of my educational career that's led me to where I am in my career now, which is being vice president and owner of civil engineering firm with 4 offices in California, dealing with some really interesting projects across the board, from flood control to water resources to water treatment to habitat restoration, et cetera. So again, that's just my background here, and just to give you some context to that as we go through this particular project. And on this project, my role was to provide some design input to really more kind of the functional mechanical elements of this project. But we're part of my firm, Kjeldsen. We're part of the project design team, working with an extensive team that developed this project. Overall, the project was sponsored by Reclamation District 108. They are an entity that's responsible. It's a local governmental entity that's responsible for managing and maintaining primarily flood control facilities, but also water resources facilities northwest of Sacramento, north of the city of Woodland, if you know that area. So they were the primary project sponsor at the local level, being able to implement this project. But this is an example of a kind of a broader interagency collaboration to address an issue, a challenge that has been kind of ongoing, and there's been a lot of efforts to improve conditions regarding salmon migration, salmon habitat in the Sacramento River. In this image here, you can see Sacramento, the Knight's Landing. I'll go into an image, a couple other maps here, kind of showing the significance of those. But what we're dealing with here is that red line. That red line is what's called the Calusa Drain. And it's a waterway that was constructed a long time ago to help develop agricultural production within the Sacramento Valley, which over time has resulted in some challenges regarding salmon migration and salmon spawning here, that we'll talk about how the project is intended to address that. Again,
Neil, I love
project
how
sponsor. Yeah,
you've
go ahead.
outlined the different stakeholders and skill areas relevant
Yeah.
here, and it just reminds us all a project requires so many different talents and skills, right? So our students that study environmental science might think, what can I do with these things I'm learning and doing in college? And just seeing, everything from GIS specialists and now project accountants. Could you tell us a little bit more what the project accountant's role is before we continue?
Yeah, sure. So this is a grant-funded project, and so Department of Water, California Department of Water Resources were one of the funding sources, and so part of that grant funding is a need to really precisely track the use of funds. So number one, developing budgets that you can operate under, but then as you go into the construction, I'm going to go into this over here a little bit later. This is a $16 million project, is to be able to really precisely track what happens with those funds. As a publicly funded project, that transparency is very important. And so having project accountants that are dealing with the expenses, tracking the funding, tracking the use of funds, being able to report that back to Department of Water Resources was really important. So that's a, and again, you look at this and say this is seems like a construction project, but there's a lot of different people with different skill sets kind of under the hood, if you will,
Hmm.
involved with making this successful. So absolutely, the project accountants are one there. Got to go back here a little bit to some of the other partners here. The SWC, that's the state water contractors, and why they were involved in this is the need to protect salmon comes down to some of the changes in the landscape in the Sacramento Valley as part of the Shasta Lake and the state water project, and then the users of that water. So, for example, at the state water contractor level, they're working with entities that are dealing with water policy, dealing with broader policy elements such as fisheries challenges. Um, and part of that work will also be integration of people that understand geographical information to be able to integrate mapping, understanding of landforms and landscapes, and how those affect things like water uses, habitat, habitat conditions, waterways, and things like that. So again, from the kind of the big picture perspective of the development of the project, Fred, it had individuals in these various with backgrounds in these various areas to help understand and bring information together to be able to come up with a solution.
Great.
So the going to the objective of the project, really the purpose of this project here is to rescue, the other term is salvage, but we're using rescue here, salmon that would otherwise, instead of going up the Sacramento River here, shown in blue, would be um, uh, driven to or uh, kind of would take a wrong turn, if you will, go up the Colusa Basin drain. The problem with that is that drain is not good habitat. It's not interconnected with the Sacramento River. So as you can see in some of these photos here, historically there have been a lot of not quite this right word, but almost ad hoc activities to try to address some of these challenges and issues. And so we have people, primarily biologists, environmental scientists that are working with temporary systems to come in and try to manage the fish that would wind up being uh, um, uh, directed towards the Colusa Basin drain. And so these activities here, there's a lot of effort and time put into trying to improve conditions, but in the end, it needed additional infrastructure. So again, there's a lot of background here in terms of effort and scientists and professionals working to try to improve conditions, um, uh, either downstream of the Colusa Basin drain or within the drain itself to be able to improve survivorship of salmon. So in
Hmm.
this example here, this device here is called a fike. It's a device that you would put into the river to keep the fish from continuing to migrate upstream, because in this case upstream is it's kind of a dead end. It's not suitable fish habitat there. And
Hmm.
then on the other side of that fike is to then be able to capture those fish and be able to take them over to the Sacramento River so they can continue on their way. The challenge with this system here is that it's difficult to operate, and it had a lot of stress on the fish. So, for example, here in 2013, there were about 300 fish that were rescued in this kind of instance here. But of those 300, only one survived because they're
Oh,
very stressed through this operation. So again, people working to try to improve conditions, but just didn't have the infrastructure to be able to be super effective at that. So just to go into where this is a little bit more, The big picture, you saw the Sacramento River. You can see that here in blue. And then red is the Colusa Drain that goes on its way on the west side of the valley. Again, it's kind of a dead end. It's not suitable habitat there. Um, Under certain flow conditions, when there's a lot of flow coming down the Sacramento River, you can have some of these flood control structures like the Sutter bypass, the Yola bypass have water in them, allows the fish to go up into those bypasses, and then they get diverted. They get for some of the flow conditions will attract them to the Colusa Basin drain, or in this case, what's in green here is the Knights Landing Ridge Cut. So over years, at kind of understanding these challenges at the policy level, Department of Water Resources, Fish and Wildlife, we're able to start to implement some structures that help these conditions. So one of those is the Knights Landing Outfall Gate. K-log is shown right here. That's a structure that would keep the fish from coming up the Colusa Drain directly from the Sacramento River. But that didn't address, under these certain flow conditions, the Knights Landing Ridge Cut, which was another drainage channel that interconnected with the Yola bypass. So when you had high flows in the Yola bypass, then you'd have fish traveling up that. So this project here really came in and kind of provided a structure to help avoid this fish coming up that section right there. Again, as you look at this, this is I'm talking about this again from an engineering perspective, but understanding the nuances of how the system works and functions, understanding and providing input to things like policy, those are all aspects that individuals coming out of environmental resources, environmental studies, environmental science backgrounds, geology, fisheries backgrounds, et cetera, are all involved in understanding these nuances, understanding how these systems work or don't work. And then ultimately being part of solutions that a team of people, professionals coming up with solutions. So that's really what happened in this case here was an understanding of some need by local entities using the water, people drawing water off of the Knights Landing Ridge Cut or the Colusa Drain, being impacted, their operations being impacted because of the impact to fisheries. And so trying to come up with a solution that served both the agricultural water needs and then really improving the fish conditions here in this segment. So again, there's a lot of individuals and professionals, if you will, under the hood in terms of developing the project solutions here.
Yeah, you'd mentioned some of the stakeholders included the Reclamation District 108,
Right.
and then the state water contractors, and then California Department of Water and Water Resources. They all
Yep.
had to come together around this project. Can you kind of help us understand how did they come together to have this common goal?
Yeah. So that's I'm just going to go back here a second to go to this right here. So it's and it's multiple levels, and people have different kind of positions within either a policy perspective, regulatory perspective in some cases, or stakeholders in circumstances. So really, a lot of this is driven by some biological opinions that were developed through National Marine Fisheries Services in terms of the impact to salmon in the Sacramento River. And the basis of the impact has to do with a lot of different complex things, which is more than I have a knowledge on myself, but have enough of an understanding to talk through some of the solutions. So really kind of starting at the top here, state water contractors. That's a consortium of people that use water that's delivered out of Shasta Lake. And so that organization represents individual growers that are pulling water off the Sacramento River or even water coming back up out of the Colusa Basin drain. Their operations were impacted because they had to let flows go through at a certain time. They had to have water flowing enough to be able to maintain the fisheries conditions. And so they were interested in a solution. Department of Water Resources, California Department of Water Resources operates Shasta Lake, and they're required to take certain actions to improve um, improve conditions for fish. So you have the users of the water, you have the operator of the water
Mm-hmm.
system. What I don't have on it as a logo on here, but they are very involved, is the California Department of Fish and Wildlife as well. You have these various entities that are responsible for certain objectives. And in the end, you come down to Reclamation District 108 and their involvement as a representative part of the state water contractors. They say we need to provide a solution. We have the known challenge, we have the biological opinion, which has objectives for us to meet, but it doesn't necessarily offer solutions. It has the end goal, it has the end post
Mm-hmm.
that you're trying to go towards. So in this case, Fred, you have RD 108 saying, hey, we need to provide some solution here and improve conditions. We have an ability to do that. DWR, you're part of this program and operation, actually through some state funding and ability to help us fund the project. We can implement the project if we're partnering with you in terms of funding. And then, of course, state water contractors overall, from a policy perspective, are supporting the project developed forward. So Fred, that's kind of how that collaborative element there of the different entities came together, is at the local level being able to implement a project and implement a project quickly, but then working with the state departments, water resources, fish and wildlife, Northern California associations that are consortiums of stakeholders being able to support the project both from a local level as well as a political level. So that's what's a really an interesting aspect of this, is being able to have this group here come together for that solution.
All right.
So Wallace Weir as a solution was developed, again, really led a lot by RD 108, but then input from DWR, Department of Water Resources, input from state water contractors, fish and wildlife, et cetera. So again, the challenge that was trying to be resolved here was some of these conditions that were less than ideal for being able to protect fish. So here's a case where you can see fish that was rescued downstream of one of these temporary fikes. This is a lot of stress on that fish. So it's hard with this infrastructure to be able to really be successful and have high survivorship of the fish when they're collected and relocated.
Mm.
So the existing system that was there was just a kind of an, not if it's the right term, but kind of an ad hoc berm that was constructed with some gates in it to help the condition to, under certain flow conditions, make sure that there wasn't a path for fish to go upstream into the Inclusive Basin drain. But then I'll also allow for some backup of water during certain conditions so that users of water could still draw out of the this channel here during certain parts of the year. It was, again, kind of a low tech solution. Some low tech solutions are great and they're the right solution. Others, sometimes they kind of show their ability to not be very, very effective. So in this case, here, this berm, you'd have some high flows come through, it would get washed out. Big portions of it would just kind of get blown out. That sediment would go downstream. It would lose its effectiveness to be a barrier to fish. And this is a case where we want this barrier. We don't want the fish to go up this way,
Mm-hmm.
right? We want them to go the other direction. And so trying to have some barrier activity here, this would kind of get washed out. So again, there's a team of people that were operating, maintaining this system, that just saw that it was, again, less effective than it could be. But then the challenge came in, is what do we do? What's the right solution? How do we fund that? How do we construct that? So the proposed solution was to have a combination of facilities, and really kind of four primary elements to this. One was to replace the kind of the simple berm that kept getting washed out with a more substantial structure that could resist floods, be effective year in, year out, and then have a longer life of that particular infrastructure. And then coupling that with a structure that both allowed flow to go through during flood conditions, um, but then having this being able to back water up as needed to be able to provide access to water for the users, upstream users, again, agricultural users in that case. And this structure here to improve the ability to allow water to go through it, but then to keep fish from, jumping um, the inflatable dams and then continuing on their way upstream. And so there's a particular weir type of weir that's installed as part of this. And then lastly, having a structure facility that provided for a capture and rescue of any fish that did wind up coming up this way here. And so this is, again, this is one of those areas where the fish rescue structure really needed to involve people that understood things like fishery biology, water quality, dissolved oxygen conditions, flow conditions, and things like that to be able to adequately design that structure.
So,
Um,
Neil, could you help clarify how these objectives were arrived at and the entities and who was involved in distilling down what exactly those objectives would be?
Sure. Yeah, and there's a we're often working within a lot of guidance, guidelines, design criteria that have been developed over years um, by say National Ocean Atmospheric Association, National Marine Fisheries design criteria that maybe has been developed through Fish and Wildlife entities. And so that criteria, I mean, those are documents that we as engineers will look through. It's like has metrics, has numbers, and we need to meet. Um,
Mhm.
Velocities, dissolved oxygen levels, and things like that. But really, what goes into that is the science. So the science of understanding what are acceptable conditions for fish, dissolved oxygen conditions, for example. What are flow conditions that would attract fish? And so so we're working with fish biologists to understand those conditions and designing this structure right here, the fish rescue structure, so that it had the right velocity of water, had the right amount of water and velocity, had the right dissolved oxygen conditions, so that the fish would be attracted to this and would come up into it. So that's where you kind of have the multiple backgrounds of people involved. Um,
I would imagine that being consistent with that National Marine Service's, opinion, there's probably a
mhm.
lot of more nuance that really the slide couldn't go into, but I imagine there was quite a lot of criteria on that as well.
Yeah, and so from the biological opinion perspective, it's the kind of the broader, what's the impact to the resource, what's the impact to the the particular species, what are the objectives for restoration of that species. And so the opinion is going to be that big picture policy document that then entities such as RD 108 or even Department of Water Resources have to then take and say, how do we meet those? What do we do to meet those objectives? Where can we make improvements to improve conditions for fish? So while the opinion sets the goalpost, sets the direction, identifies the issue and challenge, and sets the goalpost, how to get there, the opinion doesn't do that.
Hmm.
That solution then needs to come from people that are going to look at the broader circumstance, look at the multiple uses of water and the landscapes and the environment to come up with a solution that goes makes steps towards that objective. Okay.
All right.
Again, so this structure, we had multiple objectives. The being able to divert trap fish, be able to take them over, have them rescued, and have that available at least 95% of the time. Make sure the fish don't continue their way up into the Colusa Basin drain. Try not to impact water users, because the water users are partners in this operation. Can't avoid and ignore them. Make sure that this structure can work to also provide the water available to them, and then ultimately not impact flood flows. So all of those requirements, again, under this biological opinion here section of action 1.7.
I'm sure the documentation for this project is hundreds of pages, yeah?
Yes, between like the environmental document, probably so a couple environmental documents, the CEQA, California Environmental Quality Act document, and then the NEPA, National Environmental Policy Act document, both of those that really address the project, its effect, as well as the construction. And that's one where, again, a lot of different people coming from different backgrounds, biologists, air resources folks, cultural resources, archaeologists that are involved in those document preparation to make sure that any impacts are identified and that the project design then is such that it mitigates those impacts. Yeah. Okay. So going into some features of the project here, we have the armored berm, which is this structure right here. The water gates, so these are inflatable gates. They're the kind of the manufacturer style is called the Obermeyer gate. So it's actually a big balloon that pops up to allow the gate structure to come up and then controls the water. One of the concerns with those is that out in a kind of a rural area like this, for some reason, if you put some object out there, people tend to like to shoot at it. Not sure why. So a concern was we have a big inflatable balloon. What happens if somebody shoots at that? So we had a lot of discussion about how to address that. That was actually less of a problem. Another challenge that came in is beaver like to chew on the rubber on those balloons, and so there's a
Wow.
operational element that they have to address repairing the balloons because the beavers like to get in there and gnaw on it sometimes. And I think that was new. That was nobody, I don't think had seen or experienced that yet. So that started to come into play.
The one
Yeah.
case where you say go beads. Oh, maybe don't go there.
Yeah, go somewhere else, beaver. None of this one. Go chew on that over there. Yeah. We had picket weirs, so it's an interesting kind of a set of like forks that have certain spacing between them, and they're set in the water a certain space so that the fish will kind of tend to come up under the bottom of them and keeps them from jumping over the top. It's a whole design process that was really perfected in Alaska for those picket weirs. So we applied that here. Again, the fish rescue facility, which has this channel and then a device up here. It's called a fish crowder. That once the fish come in, they go through these gates and they don't want to come back out. We're able to close that, bring that structure together, so that kind of brings the fish together and then brings them to the surface, because this is the place right here where right now we continue to have the California Department of Fish and Wildlife will come out here on a regular basis and rescue. They say salvage, we say rescue those fish and then take them over to the Sacramento River. And so this is all designed here again with biologist input. Can't see my mouse, sorry, cursor there. To really be able to minimize the stress. It's still a stressful situation, but minimize it, particularly compared to capturing them downstream in these shallow waters. But to work with them to help handle the fish here for rescue. And so this is one that was interesting. I mean, we again working with Fish and Wildlife. They're biologists. They have extensive experience with fish handling within the various fish hatcheries that there are across California. So very good experience in how to do that effectively with minimizing impact, minimizing stress, and maximizing survivorship of the fish. So we had a lot of discussion with Fish and Wildlife staff on what works, what doesn't work within the fish hatchery perspective, and adapted that to this design here. So again, so here's another close up here of that fish rescue facility. And this upper portion here is the fish crowder portion where it has a series of gates that kind of brings gently, so it's not a compactor, it gently brings them together so that, and then brings them to the surface so that they can be handled, manually handled, to be put into a vehicle for transport to the Sacramento River. And this is where we had to put a lot of time into how flows would go through this channel, would be diverted from the upstream channel, enough velocity, maintain dissolved oxygen through this, maintain the flow that comes through. Then also have conditions here where that flow rate and the conditions coming out of this exit here were enough that would attract the fish. So kind of having certain velocities and flow rates that would attract the fish. So that was all part of what went into the design of how this system is operated here.
How long did it take for this to be designed, let alone constructed, but just the design features? What's the timeline on that?
So let me go down to here's the schedule slide here. So we did a fast track design. So 2015, 2016. So I want to say we were about, again, this is a while ago now. This is we're 20 or 10 years on this now. We about a year, I think, is what we had on design. Starting off with like geotechnical geotechnical investigation of the soil conditions. All the environmental works started early. So you
Mhm.
had people that were really looking at the habitat conditions here and kind of mapping those out. That's where people with like a GIS background will get involved in terms of mapping of habitat, mapping of um, existing conditions to be able to understand risks and potential impacts from a project from an environmental perspective. So that all that happened early. Then we go into kind of really the nuts and bolts design of the structures and the earthwork and all that. That was probably within about the first 6 months or so that started. So about a year or so in terms of design before this went into construction. And during that whole time, we're also going through the permitting process and dealing
Permitting,
with
yeah.
various permits involved here. Yeah. So again, you can see here, this is the construction. So overall, this project was $16 million. Um, fast-tracked, fast-paced project. Kind of the collaboration in one aspect of this that RD 108, Reclamation District 108, employed was to have what they call a team of experts. So this is a team of people that were stakeholders that had very different backgrounds, understanding of different components of this project to make sure that issues and challenges were identified early on and they were resolved. So again, this is part of kind of an expanded group of people that had environmental policy background, had a biology background, agricultural water use and agricultural economics background to kind of understand those aspects in terms of the water use component here, understanding flooding, understanding regulatory requirements overall. And so that's part of one thing that Reclamation District 108 did is convene this team of experts with various backgrounds to be able to address issues quickly and then keep that design process moving forward.
Yeah, could you go a little bit more into the acronym for,
CEQA,
CEQA, that's
yeah,
CEQA. That's California
Environmental Quality
Environmental
Act.
Quality Act.
Yeah,
So, and they need to, the permit needs to comply with that act, right? And then NEPA, could you remind me what NEPA,
yeah. NEPA is the National Environmental Policy Act. And so
right?
those are so the CEQA, California Environmental Quality Act, is the California version of the federal NEPA. And so those two acts require a certain process that requires entities, public entities, to go through a process to evaluate the potential for impacts to the environment as a result of the action of the project. And so NEPA, National Environmental Policy, you're going through understanding, evaluating what the construction. So for example, if this construction is coming in here and if it's permanently removing habitat, that needs to be identified as part of that NEPA process. Same thing with the CEQA, the California Environmental Quality Act. It's a similar process. They overlap fairly well, but with some additional steps that the CEQA process requires. So these two, you're really, again, you've got a broad set of people that are coming in and looking at this from an environmental perspective, again, this is soil scientists. You've got again, biologists, cultural resources, archaeologists, really understanding what the potential impact is to this area here under the study that happens under NEPA or CEQA. So that's again from a environmental someone that's looking at career paths from an environmental perspective. That's one key area where you can work with either public entities or a lot of private entities that are involved in this area here. In this case, the consulting firm that we worked with was ICF, and so they took on the CEQA and NEPA documentation processes there.
Right. Okay, so ICF, right.
Yep, ICF. Yeah. They also helped with some of the permitting. So the section 404, section 401, those are sections of the federal water code that you have to comply with in terms of again minimizing your impact from the project under section 404 and 401. 404 deals with fill within waters of the U.S. And so constructing this berm, making sure that the long-term effects and impact of the fill of the project are positive, not negative. And so even though this project was a project to benefit biological resources and benefit fisheries, we still had to go through these processes to make sure that our actions of constructing these structures here didn't have incidental effects, what we call take of either impacts to endangered species or their habitat. And so that really is part of what comes through all of this CEQA, NEPA, Section 404, 401 processes, and then input from National Marine Fisheries and the U.S. Fish and Wildlife Service in terms of looking at this. Okay. So again, the project moved forward and was constructed, started in 2016, early 2016, and then really finished by fall of 2016, so that it was ready by the winter of 2016, 2017. So again, a lot of work that happened very quickly during this period here. Get some of that work once we got towards the end of it started to happen when the rain was coming. So there was a need to make sure we got everything buttoned up before the floods came. So some of these picket gates that were installed, we started to have some rain events there. Had to make sure that we were maintaining control of the entire site in terms of runoff. So there's a lot of requirements here to keep runoff contained and minimized there during construction. Overall, some design parameters here to this. This is the picket gate, and this normally comes up to control fish coming through there. So gates are designed to normally pass 4,000 cubic feet per second, but then also be able to pass under a flow condition up to 20,000 cubic feet per second. And then have these gates here raised and lowered to be able to control levels upstream. Then overall, just maintaining water quality within the fish rescue system too. So, kind of, towards the end here of the presentation, but just to look at the past, really a snapshot of the one of the past years of the past 10 years of operation of the system. It's been very effective. Mentioned before that the system was constructed, the roughly 300 fish were rescued in 2013. Of those, only one survived. At this point, the system here for 2023 and 2024, about 800 of our primary concern species, the Chinook salmon, were captured at this location and captured and relocated. This is on the annual basis, so all of them on that annual basis. Of that, about 224 were from the critically concerned winter run. And so that represented about 30% of that roughly 800 2024 total winter run population. So this facility is helping protect about a third of that really critical population in that period there from 2023 and 2024. So that's continuing to operate year in, year out to be able to provide that benefit and help restore that fish population, particularly for the winter run salmon here in the Sacramento River. So overall, been a very successful project. Been able to resist flooding, so it's been flooded. It survived. This armored embankment survived the flooding that's occurred. So again, a successful project that just a lot of different people come together to make it work and to help provide benefits to multiple levels of needs and objectives.
Yeah, and I imagine that there's a lot of ongoing operation and administration of this system. So can you speak to who's involved with that and how that's been operational, I believe, for nearly 10
Sure.
years?
Yeah. So one of the key operators here is Department of Fish and Wildlife. So here you can kind of see on the far side. This is actually during construction. Still, this is that fish rescue channel right here. So California Department of Fish and Wildlife, it continues on a regular basis, comes and does the fish rescuing out of the structure. The kind of the overall maintenance of the structure is Reclamation District 108 is still involved in that to make sure that the structure is keeping up with its operational ability. So they're still involved in that day-to-day operation of the structure. So really, again, that collaboration has continued to work with those entities to be able to meet these objectives and these benefits. So some additional information, if anyone that's on this call here or viewing this recording can go find some more information. These websites here, some additional background on this particular project. Again, it gives you an idea of a type of project that's occurring throughout the West. I mean, this is an example here in Northern California, but a lot of very similar activities happening in Washington, Oregon, Utah, Idaho, et cetera, for these similar types of challenges that we're trying to improve how we as humans are impacting the environment to be able to improve things, but be able to still maintain, what uses we still have of the land as well, but minimize those effects on fish and wildlife, et cetera. So that's the end of my presentation here. And so if there's any other questions of kind of the project or the team, those are involved in this process, or general questions on how to navigate a career path, trying to find out jobs, opportunities out there, certainly be happy to provide any input.
Yeah, and Neal, those are great links. I'll make sure to pass those along with this recording to our students in the college. With the little bit of time that we have left, I wonder if you could speak more to, career opportunities in water resources, habitat protection and enhancement, and policy. From where you're at in your profession, where do you see these opportunities for students to be looking?
Sure. Yeah, I think we're going to continue to see more and more investment in kind of in some ways repairing some impacts that have been historical impacts, improving conditions, really certainly throughout the western states. Going to continue to see that investment and continue to see the collaboration as well between the various stakeholders, regulatory entities such as National Marine Fisheries, policy entities such as your various state water resources groups, as well as those stakeholders that are typically, when you talk about water, biggest one is going to be agricultural water use. So from a surface water perspective, habitat perspective, groundwater perspective, those are all really big issues, big challenges. So you have career paths that would be kind of a public sector paths. You have career paths that are private sector. The public sector, one thing to think about is the public sector can be very broad. You can look at federal entities, National Marine Fisheries, USGS. There's a lot of opportunities still through those paths. But what I think you're going to find more and more is that having some expertise and at the local level is going to become more and more important, more opportunities. So in this case here, Reclamation District 108 that has a variety of engineers, environmental science staff, geologists that are part of their staff that are dealing with some of these policy elements, and so they'll have folks on the public sector that more at the local level with job opportunities. Likewise, the private sector. So the private sector, you've got environmental firms. ICF is one that we listed here. KSN, we employ engineers, geologists, GIS specialists that help us with a lot of these project development aspects. And so you can look at the both the private sector and public sector as opportunities. And I think as a student is to work with people like you, Fred, in terms of finding those opportunities. So people that are engaged with the university through Handshake. That's a key platform. Kind of look at what areas those entities are involved with, and try to match up what your interest and your education is with what those entities do. So spending some time and looking at those profiles through Handshake, I think is a key one for students.
Yeah, and I send a weekly newsletter, try to aggregate job opportunities. I tell students looking at position descriptions, even if it's not a job that you're eligible for today, it's going to teach you so much about what to be aiming for and who to start building relationships with.
Yep.
Private firms are probably seem maybe intimidating, but if you get to know somebody there, that can open up opportunities and just kind of give you a broader perspective. And it
Yeah. So
looks like we're seeing your LinkedIn page here.
yeah. Yeah. So one thing I want to promote here is start, as students, start your LinkedIn page early. I mean, freshman year, there's no problem starting that. You start to have some history there, and really you're able to kind of work the LinkedIn, work your LinkedIn profile, start to make meaningful connections, and make connections with connections. That's really what you're trying to do here through this. So if I kind of look at my network. So someone were to connect with me, not that I'm trying to have a whole bunch of people connected that are connected with me. I want these to be meaningful,
Yeah,
but
right.
this is the way that you have an opportunity to connect with other professionals at a broad level. So, you'll look at my listing here. There's a lot of engineers. Well, that's where I'm in an engineering world, but there's also people that have different backgrounds that you may be able to connect with and make a connection with the connection. So being able to use LinkedIn as a way to expand your network, I think is a good thing. Also, look at your local circle. So your parents, your grandparents, your uncles, aunts. So who do they know? Who do they have connections with that they might be able to connect you with in terms of opportunities? I would say for students, don't be shy to reach out to people. Professionals will spend time with uh, students just talking about their career. So, a very easy thing to do is if you find a connection that maybe is in the area that you have an interest in, a very easy thing to do would be to reach out to them, say, hey, would you mind having coffee with me, having, half-hour discussion? I'm at this point in my educational career. I'd like to just get some advice. I'm looking for an internship here coming up this summer, but how would you suggest I go about that? That's a very easy thing to be able to have a question on, to be able to open up a discussion. So chances are that person's going to say, hey, here's some suggestions. You do this, this, and this. Talk to these people. Or even better, it may be that person says, you know what? We have an internship coming up this summer. Would love for you to submit your application on that. You never know.
Yeah. Hmm.
So it's taking that first step and doing that outreach is very important.
And I'm sure, Neil, you would probably not be surprised to hear that a lot of employers say exactly what you're saying. A lot of professionals say what you're saying is it's sort of the student just getting out there and being willing to do that thing we call networking. It's always going to be useful and valuable to get out of your comfort zone and make connections, make
Yep.
relationship building a priority. Yeah. Well, I want to thank you, Neal, for all this great case study content that you provided today. I think it really helps give some concrete examples of ways environmental sciences students can engage in projects. It starts with kind of an understanding of what's happening out there as a basis for taking action, building connections, knowing what companies they would liaise with if they were in different roles, that sort of a thing. So thank you for your time. Is there any final closing words you'd have as we wrap it up?
No, just again, thank you. Thank you for this opportunity here as well. From again, a career perspective, certainly I would be happy to provide some input to folks that are looking at, ways to approach their careers, kind of have a unique combination of background from environmental studies and engineering perspective. So, love to support people in even just a call, look at a resume, give some ideas. I'm certainly open to that. Would love to help fellow beavers in that.
Well, great. Well, thank you, Neal. And you and I met at the career fair last fall, and it's just a good example of how you never know who you'll meet at a career fair and where that can lead. So this
Yeah,
has been
absolutely.
really, this has been great. And thanks for your time today. And we'll add this to the newsletter, and you'll probably have students reaching out to you. I'll provide your contact information.
Excellent.
Thanks so
Appreciate it.
much.
Thank you. Thank you.
Okay,
Bye bye.
bye-bye.